Ladies and gentlemen, a very warm welcome from our side. My name is Roman Stickler. I'm new business development manager for UTM systems at Frequentis. Together with my colleague.
Hello, my name is Ulrich Kaage. Also a warm welcome from my side. And I am swim solution consultant at Frequentis Comsoft.
Today's presentation we split into two parts. In the first part, I will tell you about the very dynamic field of unmanned traffic management and its latest insights, while in the second part, my colleague Uli will take over to give latest insights on swim.
Yes, okay, thank you. So, first part with Roman.
So let's start at the beginning. The aviation industry's digital transformation, together with unmanned traffic management market, are additional drivers to ask for data harmonization to be monetized by additional services. A recent European study has forecasted that the total drone market will reach a total of $10 billion annually by 2035. There is therefore an opportunity to look at the airspace integration of drones with a specific view on providing air navigation service providers with additional revenue streams. The convergence of air traffic management and unmanned traffic management has already begun, with a focus on safety on the one side and the dynamic digital world of UTM conversion on the other side. This will lead to potential additional service provision. For commercial drones to reach their full potential, one challenge is still to safely and securely integrate both ATM and UTM, and allowing all users to equal access harmonized finite airspace. The main requirement to overcome this challenge is a high degree of digitalization and automation. Countries must be able to ensure a high degree of freedom to use the available airspace if it is to be economical sustainable. The key is to enable scalable commercial use of drones on the one side and to allow ANSPs to offer their services also outside of controlled airspace. The service provision to safely share the same airspace and to leverage to a higher degree of traffic volume requires both ATM and UTM to embrace digital tools. Sharing one sky refers not only to the actual airspace, but to data, to procedures, and also infrastructure. To close the value chain between client of a drone operator and an ANSP, it requires additional new services, new data integration, new data models, and enhanced interoperability as well as interconnectivity. Frequentis is leveraging a system-wide information management, which comes with a service-oriented architecture, lowering costs and reducing integration costs. And it allows the development of third-party tools to be added to the platform. An open and flexible microservice infrastructure is key to future-proofing today's investments in the ATM systems. The Frequentis Mosaics Swim supports seamless information exchange between air traffic controllers on the one side and UTM operators on the other side, creating a unified, shared understanding of the airspace situation. On top of Mosaic's SWIM, tailored services can be developed for each entity in the value chain, ensuring a flexible but strong architecture to be connected to the airport, basically managing the airport Internet of Things. Mosaic SWIM comes with a service registry that provides tools for all agencies to discover services available by the publisher. As a single source of truth, Mosaic SWIM supports all stakeholders in the ecosystem with a focus on data accuracy, integrity, consistency, and timeliness. In a nutshell, summarizing the advantages of Mosaic SWIM. Mosaic SWIM minimizes time to market. How is it doing that? Mosaic SWIM enables to integrate hundreds of different data interfaces to be connected in shortest time period. And we as Frequentis, we understand the protocols. That was too fast, sorry. As of April 2021, the European Union Aviation Safety Agency adopted 3 packages to implement UTM U-Space regulation. These are actually the first regulation worldwide. The U-Space regulation will come into force by January 2023. The U-Space services were basically designed to enable drones to safely, efficiently and securely access airspace. In Norway, Frequentis already provided such a UTM system at our customer Avinor Air Navigation Services. We provided there a CIS, a Common Information Service function, together with U-Space service technologies. The Frequentis CIS offers ANSPs a ready-to-deploy backbone, which is bridging the ATM and the UTM world, based on Mosaic SWIM and UTM services, which are required to safely manage drones along the manned aviation. All these services have already been proven in different trials, in live trials. For example, a BVLOS, that means beyond visual line of sight flight from one city to the other, covering hundreds of kilometers. That's one use case. Another one supporting search and rescue operations, and also drone flights, fleet management has been carried out in controlled airspace. The services, for example, covers fleet management, flight planning, and an ATM integrated authority service, for example. To unlock the potential of automated flights and approvals, which will be, of course, way more in the future from now on, Frequentis supports an open market regime. Partnering for success. What does it mean? We as Frequentis, we know both worlds. We know the UTM as well as the ATM business. At Frequentis, we have the right skills and the right partners to offer a secure and scalable UTM system. Many European countries are currently pushing to get economic plans on how to integrate UTM in the future and how to integrate drones in their airspace. This is important. Most important is to have a pathway on how to really do it safe and securely, and also to have a scalable solution for any future activities in this field. With the right technology and the right partner, it is possible to close the value chain between the ANSPs on the one side and the operators and clients of drone operators on the other side. Thank you very much. I will hand over now to my colleague.
Thank you, Roman. Can you hear me, actually, a little bit? Just, he can hear me only a little bit. So I can also speak louder if necessary. But yeah, Roman, thank you very much for the heads up for UTM. I think this was very interesting. You heard something about the CIS, Common Information Services, and you heard something about Mosaic Swim. You might ask yourself, what is Mosaic Swim? Mosaic is a product name, and Swim, who knows what Swim is? Hands up. Okay, some. Cross-check, who does not know what Swim is? Hands up. Okay, there are some undecided, obviously. Anyway, if you don't know if you know about Swim or not, please stay tuned for the presentation. So what you see here is the general picture we have to explain Swim, what Swim is. And I will quickly do it for those that don't know about Swim. So Swim is everything basically except the IP-based network and the applications on top. Swim is a concept for a service-oriented architecture, and also what is called a registry, which is some kind of yellow pages, so that you can find the services that are offered by a system, by a solution, and so on. So, and the Swim also covers services, information, and governance, and some infrastructure on top of the IP-based network. So what do I have to remember of Swim? This one, swim or die. So we have to do Swim in the to survive the future, where it comes more to artificial intelligence, machine learning, where we need lots of data. And why Swim is crucial here, I want to tell you in the following presentation, following slides. And this is also a good example what we see here, because this is also Swim, but it's another Swim. So what you learn here depends on the context about what Swim we are talking. Yeah, I will talk about another Swim, but also in two different contexts. One context is the regional context. It is a whole region like APAC, like Europe. There's a Swim development, and I will talk about the Swim within ANSPs, which is a completely different thing you will learn. Yeah? So first, let's talk about regional Swim. What does it mean? The idea is that we can, in one region, we agree on data formats, we agree on standards, and we are able to exchange between ANSPs, for instance, and with other stakeholders, information. Yeah? Data is shared, principally. So we need common data formats, common standards, so if everybody implements them, he can exchange the information with another ANSP. Yeah? Here, like a national ANSP. So what does he need to do to become part of this regional network? Either he has a Swim infrastructure already, so then he has means to connect, or he needs gateways, for instance. So an ANSP could keep his own infrastructure as it is, and just use a gateway at the border to convert the incoming data from Swim. If you ask what kind of gateway could this be, then I invite you to the Frequentis booth, because of course we provide such a gateway to connect both worlds. And if you want to learn more, just stop by at the booth. So we see here we need gateways to access the data. Yeah. But now this is a region has many ANSPs, yeah? And so they connect. Maybe they connect to the regional Swim or not, they connect to each other, but they all have their own infrastructure. And here we come to the other context of Swim. It's not the regional context. Yeah? We see here international exchange formats. I had an example we have helped to establish such a regional swim network in the APAC region together with a company called PCCW. We teamed up, so we provide the infrastructure, the software that is required to establish such a network. And PCCW, they use the CRV to distribute. The CRV is a common, what's it called? Common regional VPN, which is a network like the PANS in Europe. It's in the APAC region. Yeah. So this was the regional, and now the national swim. It's completely different. National swim also means service-oriented architecture. So in principle, it does not mean anything different from the regional swim. Breaking up data silos is a big buzz sentence in context with swim. Why? I will explain. Also unlocking data for automation, AI, ML. So if we have these algorithms and want to train them, machine learning algorithms, we need lots of data. So somehow we need to access this data. And one thing that's the development is moving away from highly integrated systems. In the past, systems at ANSPs were really masterpieces of integrating everything into maybe a controller working position. Today, we want to move away from this because it's not only the controller who needs access to the data, but also our machine learning algorithms. Yeah? So instead of integrated systems, we want to move to interconnected systems. And this is really a challenge actually, because if you look at a national swim, if you look into an ANSP's infrastructure, he usually has, let's say, 3 systems that have their own database that do a certain task, but maybe they are not connected, or they are connected with the lowest common denominator, maybe AFTN or something like that, which is an old data format. So how to get the data out of these systems? And this becomes even more complex because it's not just three systems an ANSP usually has, it's about 30 systems. So you have not one problem, you have 30 problems, maybe. So how to get the data? The problem, most of the data is locked in different systems, in different formats, maybe sometimes it's even not available in a database, but just in a log that is written. Yeah? So we have situations where we pass these log files to get the data we need, for instance, to train machine learning algorithms. So what can you do? Ask your vendor of your system if he can swim enable this, if he can add the interfaces and can make the data accessible. This is one way, and I think this is also the way it goes. Yeah? There will be more and more swim-enabled systems in the future. So if you have time and you're not in a hurry, it will come as an upgrade maybe. Yeah? The other situation is you maybe would like to expedite this move to the swim, so then you need to establish a swim infrastructure, and you need somehow software that accesses the data anyway. As I said, maybe through a log file or something. And now we close the loop to Mosaic Swim, which Roman introduced, which is the core part of the of our UTM Common Information Services. Also Mosaic Swim, the same software, is the solution also to this national problem. Because with Mosaic Swim we can implement very quickly various services. So maybe access some proprietary data from a system, convert it into a common format like AXM, FIXM and so on, and then provide it to the whole infrastructure. Yeah, we have examples, for instance, a trajectory service is deployed at an ANSP, and there are already 4 systems accessing this trajectory service. And this was new because each system in the past did its own trajectory operation based on different sets of data, and you know how it goes. If you look at these trajectories, they may be different because different algorithms used, there's different versions. Yeah? And here is really the possibility to create a swim network, to create services, to register them in the swim registry, and so seamlessly move to a service-oriented architecture. If you like, Mosaic Swim is to jumpstart your swim environment. Yeah. Okay, and a little bit more explanation what makes Mosaic Swim so special. If you look at standard ESBs, enterprise service buses, message brokers, and so on, these usually are commercial off the shelf and know very little of our ATM domain, and they also know very little of the UTM domain. So they just cover a certain degree of your needs, but not all. With Mosaic Swim, it's different because we are developing this in the ATM and UTM environment. We add a lot of ATM-specific and UTM-specific functions. And if they are there, you don't have to reinvent them. So we provide a very rich toolkit right from the beginning. Also with a message broker, with a registry, and here again, microservices for ATM and UTM. Also interfaces to a lot of systems. We have connected already ATC systems with AIM systems and so on. Yeah, so Mosaic Swim is a good tool to start the swim developments. And maybe one example, within an ANSP, how connecting systems could provide new value to an existing system. And the example here is an SMAX. What you see here is the display of an SMAX system. This is a system that is used for ground control at airports. So ground controllers see all the movements of aircrafts and other vehicles on the ground. They can close taxiways or runways, and then with a display, they see that these are really restricted areas. And if an airplane comes too close, there are even algorithms for safety nets which make sure that an operator is informed. So, but if you look at the map and at the individual elements which are there, I won't read them all. It's just stop bars, runway, taxiway, and so on. Aircraft IDs, routing parameters which you don't see, and maybe also connection to a weather system. A lot of this data has in common here also taxiway closure. All the entries that have a star at the end, they all basically have the same data format, which is AXM5 data. So one AXM5 snapshot could be used to automatically display or render everything. The problem currently is that it's not coded as AXM5 data, and even worse, you find each of these elements in different data sets. Sometimes it's still the aeronautic information publication, so it's a PDF. Yeah, it might be some kind of GIS format which you have to convert and then to configure the system. Here it is displayed. So, for instance, AIP is in a PDF file. You need this for the aerodrome maps, for the runways. Sometimes it's also in a computer-aided design file, which is not a GIS format, and so on. So, what you maybe also realize, setting up such a system in a project is really a lot of work to get all the information, to convert it all into the correct information, to make sure that there is no systematic error or some human introduced error. So it's a lot of pain. And when the system is running, you usually have to update the configuration from time to time. Yeah? Moreover, if there's a taxiway closure, which is a NOTAM, you have to enter it manually. And if you forget it, the taxiway stays open, maybe there's a construction site, and so this is really a danger, yeah? A safety risk. But what we could do is, again, for instance, just looking at AXM5 data, with one source which we have usually in the AIM, we could export all this information automatically, and instead of manually loading them into the system, also automatically load them. And the SMAX, which has safety net algorithms, could automatically process, process this digital NOTAM which says the runway is closed. Yeah. So it would automatically make sure that no danger is therefore for the pilot if he maybe in his briefing does not have this runway closure. So, and what has this to do with SWIM again? In fact, if we convert all this information in AXM5, we convert all the flight plan related information, for instance, into FIXM. We have also weather information and so on. This could all be a data lake, if you like, in a cloud or in a local cloud at an ANSP. And so many systems, not just the SMAX, also arrival manager, departure manager, whatever system you have at the airport would benefit from this one single source and could process the information automatically. So SWIM is really the solution or prerequisite for the digitalization on national level and for automation. And once we have this, nobody will prevent us from giving this information to other stakeholders. For instance, sending it into an arriving aircraft so that the pilot has exactly the same picture as the controller has on the ground. And these technologies are already there today, so you can send information into the aircraft. But unfortunately, it's not the most up-to-date information even today. Yeah. So we could solve other problems that we have once we have this SWIM. And do much more, but I think we have not the time to discuss this. I know this presentation on the schedule is until 12:05, but this is a mistake. We only have 20 minutes, which is already a little bit more, but you're still there. Okay, so I think that's it to explain you what we can do in the ATM world with the SWIM technologies and what we already did in the UTM domain. And it was easier in the UTM because there we basically started from scratch. We could already use this Mosaic SWIM as a jump start. As an ANSP, I have the problem, I have already all the systems. They do everything, and now I need to update them. Yeah? So that's an explanation why in ATM the pace is much slower than in UTM. Okay, so that was our joint presentation about UTM and SWIM. Roman, come to the stage. Thank you very much for your attention. Yeah, if you have questions, you can come to our Frequentis booth and we will answer in detail. Okay? Thank you very much.